NASA's latest mission is the Mars Science Laboratory, or MSL. Its crown jewel is a rover named Curiosity, the most complex robotic spacecraft ever destined for another planet.
I love the fact that our rover is named Curiosity, because I think that's why she exists.
You hear us talk about her as if she's a person, because to us she is.
Curiosity's a marvel of technology, packed with custom-made science instruments, wired for interplanetary communication, and powered by a nuclear battery. Everything she needs to complete her 2-year mission in the extremes of Mars.
The goal of this mission is to undertake the search for habitable environments. What it reduces to is the search for 3 very simple ingredients for life itself.
On Earth, all living things rely on these 3 essentials: a source of energy, like the sun above or volcanic activity below, liquid water, and organic compounds, carbon-based molecules that are the building blocks of all life. Has Mars ever had what it takes to support life? This rover is equipped to find out by analyzing the rocks and soils of the red planet. Curiosity is as close as we can get to sending a field geologist like John Grotzinger to Mars.
When a geologist looks at a landscape like this on Earth, we're looking for a way to unravel what the early environmental history of the planet was. Now, on Mars, with Curiosity, we can do the same thing.
But Curiosity carries tools that Earth geologists would envy.
Every geologist has a hand lens to look at the grains that make up the rock. Curiosity has the equivalent, the MOLLE instrument.
The Mars Hand Lens Imager, or MOLLE, can view rocks up close or from afar.
We can focus the lens to different distances depending on what we're looking at, so it'll actually be better than this. Photography is really important because it creates a context for all of the other measurements and observations. Curiosity has 17 cameras. We've got telephoto capability, mid-range to near field, and we can also capture video.
To collect rock samples, a geologist uses a basic rock hammer.
We use it to get rock that is not exposed at the surface of the Earth for doing the geochemical analysis that tells us about the origin of the rock.
Curiosity has more advanced techniques for tackling rock, like a laser that can vaporize a spot the size of a pinhead up to 25 feet away. A flash of colored light is released, revealing the rock's chemical composition. The rover also has a drill that pulverizes rock and collects the resulting powder.
On Earth, we'd have to take the piece that we broke back to the lab to do the analysis there. With Curiosity, we bring the lab to the field.
The rover's robotic arm feeds powdered rock and soil to 2 miniaturized laboratories inside the rover. One lab uses X-ray beams to identify minerals. The other tests for the presence of organic molecules that may have been associated with life.
What's important about organic molecules is that you don't have to have an actual fossil of an organism left behind in order to detect the former presence of life. So we're not doing life detection, but we can look for these organic compounds